Hello everyone, am I audible?
Yes, sir, you are audible.
Okay, in today's session, we are going to start with the PLC wiring, right, with the input-output devices. In last session, we had a discussion about the addressing of the PLC. In that part, I have told you about the memory address, right? Then the memory word address and the double word memory address as well, right? So I will just quickly cover that double word memory address and then we will coming toward the PLC wiring. Okay. So here, just a minute, let me create a new slide. Okay. So we all know that the memory address is here like this M0.02 M0.7, right? And so when you combine one more like this, so this will be complete, you can say it 16 bit, and this will become a MW0, right? And similarly we have discussed MW2, MW4, multiple of 2, right? MW6, MW8, right? So these are the memory word addresses. Okay, memory word addresses, and we had discussed the range as well, 2 raised to 16, right? And when you divide it, you will get the range, and when you make it 2 raised to 50, you will get the actual value, right? The same thing will be for the double word memory also, that is the MD, MD, right? MD. So double word memory means what? We can say 32 bit, 32 bit. So we have two memory word MW0 and MW2. When you combine it, you will get 32 bit. Means when you combine MW0 and MW2, you will get MD0. The first address for the double word memory when you are going to think about to store the huge amount of data, right? Similarly, the next will be when you combine these two things, you will get the next address, that is MD4. Similarly, when you combine MW8 and MW10, you will get MD8, multiple of 4, 8, 12, 16, likewise. You can put the address. Okay, you can put the address. You will get to know these things more precisely when we will start the programming part. Okay, then at that time I will told you that how to use, where to use these addresses, because there are so many instructions in Siemens PLC where we have to use all these addresses. Okay, before that, according to me, you should know how to create these addresses and how to remember these addresses. That is the reason I'm telling you all these things, because when I will start the programming part and when I will write somewhere that MW0 and you may ask what is MW, right? So that is the reason I'm telling you. Okay, yeah. So now these are the all addresses which I have covered in last session totally. So let us coming toward the PLC wiring diagram. Okay. So for the PLC wiring, I have shown you the PLC schematic, PLC hardware so many times, right? From the first day, you can see PLC hardware, right? So, so when you purchase the PLC, you can observe same thing on the PLC, exactly same. Nothing will be different. Exactly same thing you can observe. So each and every terminal which is available on the hardware covered here. So no need to worry about that part. Okay. So here you can see we have input power supply here, right? You can see. Let me zoom it. So on each and every PLC, you can observe the input power supply, and we know the input power supply, that is 24 volt DC power supply, right? So here is the terminal. So here we will have to provide 24 volt DC power supply by using SMPS. Okay. Along with that, you can see the ground terminal is also here. On the output end of the SMPS, there is no ground provision, right? So you will have to connect to the input end where is the ground provision is there, so that you can connect and you can make the complete connections for the PLC. Along with that, you can see here is the L and M. L means what? This is the line where you will have to provide the 24 plus volt DC. And here the M means what? Here you will have to provide the negative 24 volt DC, means we can say common terminal, right? The same thing will be here also, right? The same thing will be here also. M means what? Just keep in mind, and if possible note it somewhere. M means common, okay? M means common. So here in this part you can observe the so many connections in which you can find the M, 1M, 2M, like that. Okay, so these are the so many common terminals which you can observe here only. Let me show you few things here, and I'm expecting the answer from you people. Just observe this complete section and tell me how many digital inputs are here.
8.
8 digital inputs, right? How many common terminal are for the digital input?
1.
Only one, right? Only one. Only one common is here. Okay, 1M, right? So this will be the first common, right? This will be the first common. Then this will be the second 1M. So when you provide the power supply here, this power supply will be come here automatically because the internal connections are there. So you can take the wire from here as a positive 24 volt, okay, as a positive 24 volt. Similarly, the common also, you will have to short the common every time. So when you make the connections, okay, let me show you here also. You can see on the PLC some letters like here I have mentioned, that is DIA. Digital input means the first section of the digital input. The first section means what? From 0 to 7. From 0 to 7 means what? How many inputs? 0 to 7 means how many inputs?
8 inputs.
8 inputs. For the DIA section, there are 8 inputs, and for the DIB, you can see there is only one input. Means total inputs which are available for this PLC digital input, I am talking about 9. Total 9 digital inputs are here. But on your PLC, you cannot observe these things, that is digital input. I have provided just for your understanding. After this session, I will provide this schematic so that you can practice at home. Okay. So now similarly, on the right corner of the PLC, you can observe 2M, means the next common terminal. 3M, common terminal, right? Along with that, you can see 0 and 1. These are the two terminals for analog output, and these are the two terminals for the analog input, right? Means this PLC is having 9 digital input, 2 analog input, and 2 analog outputs. Okay, so now coming toward the digital part, because the digital outputs are also the important thing. Exactly below the analog section, you can observe the digital outputs. You can see all these are the digital outputs. How many digital outputs are here? Tell me. How many digital outputs?
9 outputs.
9. Are you sure?
10.
10.
10. Okay, right? 0.
10 outputs.
Yeah, 0 to
10.
7 means 8, 9 and 10. 10 digital outputs are here, right? And Here you can see
Yeah.
for the output section, you cannot observe the common terminal. Am I right? There is no common terminal. Yes or no? There is
Yes.
no common terminal. Only the line terminal is here. Means you can provide the power supply. You can provide the power supply, right? Okay. See. So now coming toward the connection part, actual connections, we will do it here. Please mute the audio. It's a request. Yeah. Okay. So I think you can see the screen properly. Yes or no? See. What is this? Let us consider this is the push button. Okay. Hello. Okay. So let us consider this is the stop push button which we are using. Just for the more understanding here, I have mentioned the numbers also. You can also check it on a push button. You can observe these things. Okay. So we have this push button. The first one is the stop push button and the second one is the start push button. Along with that, we have this proximity sensor. The proximity sensor is having the three terminals. Okay. Positive, negative and the positive one, right? These are the three terminals which you can observe for the proximity sensor. I will tell you how to do the connection for the same. Okay, so now first of all, we have to provide power supply to the PLC. So now tell me how to provide power supply to the PLC. How to provide power supply to the PLC.
We will connect SMPS output with PLC.
Right, SMPS output, right? So on the output end of the SMPS, what you can observe? You can observe the terminal like positive V, negative V. Am I right? Yes or no?
Yes.
Yeah. So let me draw it for the more clarity. Positive V, like this. Then here negative V, negative V. Am I right?
Yes, sir.
Yes or no? Like this. Okay. These are the output section. What about the input part? On the input part of the SMPS, you can observe the three things. What are those three things? Tell me. Three terminals.
Line, neutral, and earth.
Line, very good. Line, L, neutral, right? Neutral and ground, we can see it, right?
Earth.
I'm typing with ground. Is it fine with ground? Yeah. Okay. See. So now, what is our task? What is our task? Your task is to provide the power supply here, right? So what I will do, I will just copy and just paste and using it here for understanding. So what we are doing, we are providing the 230 volt power supply, 230 volt AC power supply here. Okay, and when you provide this 230 volt AC power supply to the SMPS on output end, what we will get?
V positive, V negative volt AC.
Right. We will get the positive 24 volt and negative 24 volt. So just for the understanding, here I am using this block. Okay. On output end, we are getting the 24 volt DC power supply. Okay. Yeah. So now our task is to make the connections now. So now how to do the connections? Just a minute. Let me find cables. Yeah, here it is. Okay. So now let us connect. Yeah. This LED is okay. Now let us connect this positive. This L will go to the positive V. Am I right? Is it correct?
Yes, sir.
Yeah. So let me change the color of it. Okay. So here we have connected the positive V to the positive L, and this M will go to where? Tell me. This M will go to where?
Negative.
Negative, right? Negative. Let me change the color of it also. Okay. So now here we have provided the power supply. What about the ground? Where to connect this ground? On output side there is no ground provision. Where to connect this ground?
We can connect in input of SNPS also.
Yeah, great. So we can connect it here also, right? Here, so here we have connected. Yeah, so let me change the color of it and make it black. Okay, so here we have made the power supply connection. The connections are very easy, right? These connections are very easy. We have made it. We have provided 24 volt DC power supply to the PLC. Now coming toward the input connections. So input connections are very easy. We have options. So what you can do, you can directly connect this positive 24 volt for your inputs, or you can use this line terminal also, because these two terminals are internally connected. So when you provide the power supply here, this power supply will be here also, right? Will be here also. So what you can do, you can make a connection from this line terminal. Okay. So before that, let me tell you, you can see this is the stop push button, and this is the start push button. We are using it now. So as per the rule, we will have to connect the one terminal of the input devices to the PLC. One terminal of the input devices to the PLC. So what we are doing, we are selecting the one terminal, that is here it is. You can select any one terminal that will be connected to the PLC. So make sure that, otherwise no use to design the program, and your program will no longer run. Okay, so these are the some prerequisites which we will have to keep in mind. Okay, yeah. So now tell me, so initially I will tell you the first part, that here we are choosing this terminal to connect it to the 0 terminal. Here it is. Okay, so here we have connected the stop push button to the 0 terminal of the PLC. Now what will be the address of this? Tell me. Here we have connected the stop push button to the 0 terminal of the PLC.
0.0.
I 0.0.
Right, I 0.0 will be the address. Okay. Now similarly, what we are doing, we are using this one and connecting this terminal to the first terminal of the PLC, Siemens PLC. Now the address will be
I 0.1.
0.1.
0.1, right? Yeah, great. So now coming toward the second terminal. Now tell me where to connect this second terminal, where it will go.
0 volts. Right. It depends on sourcing and syncing concept.
Yeah, it's depending on the sourcing and syncing.
What we are giving on common terminal.
Okay, so right now these are the generalized connections we are doing, and everyone knows how to do the connection, right? Okay, so now here what we have to do, you can see here the common provision is here on output side, right? Input side, the common provision is already given here. So now based on this thing, you can tell me where to connect this second terminal, because you will have to provide power supply also, right? Because when you are connecting the second terminal to the common, there will be no power supply to the input. Yes or no? So for that purpose, you will have to connect the second terminal of the push button to the power supply. Now tell me where to connect it. Power supply means
L positive.
positive, right?
SNPS.
Yeah, positive.
L positive.
Yeah, so you can connect it here also, right? And you can connect it here also, because I have already told you that these are interconnected, right? Clear? Okay, you can connect it here also or here also. Both the terminals are same, right? L. Okay, these are internally connected, so if you want, you can connect it here also and here also, no problem, right? Okay, so now again the same thing will happen here. What will be where this terminal will go? Fourth number terminal. Again the same thing, am I right?
it will connect with
L
positive.
plus.
right? Yes, correct. It will be connected to the L positive. Correct. Okay. So now what about this common terminal? We will have to sort it.
We need to connect with negative.
Right. Negative will go to the negative. Am I right? Is it correct?
Yes, sir.
Or anything
Yes,
else?
yes.
Here?
Yes, sir.
What about this?
But we can interchange this connection.
Yeah, you can go ahead. You can tell me. I am asking. I want the answer because I know the most of the participants are very expert in the connections. That is the reason I am asking this thing again and again. Tell me quickly. Take your time. Tell me.
Yeah, M is already interconnected with main M.
Right. So that is the reason you don't need to connect the M to the M, right? You are absolutely right.
Yes.
The way we haven't connected this part here, the same way you don't have to connect this here also. Very good. Okay. So now coming toward this part, this is our proximity sensor. Okay. This is our proximity sensor having the 3 terminals. So let me extend it like this. I have drawn the actual part so that you can understand when you observe it properly. Okay. Now this is our sensor. Now tell me how to do the connection for this sensor. Can you see the terminal or do I need to do it?
The brown is the positive. We have to connect to L plus, and the black to the M, and blue to the PLC input.
Blue will go to the PLC. Will you please try?
No, sir.
That one
For
will
the
be
brown,
go
you
to
are
the
right, sir. For the brown, you are absolutely right. Let me connect it. This brown will go to the positive, right? Can I connect it here?
positive.
Can I connect it here?
Yeah.
Yes.
Okay, so here we have connected. Okay, so now coming towards the black.
The black
Actually, black is
PLC feedback.
Yeah, black will go to the PLC,
Right.
and the blue will go to the negative.
0.2.
Right. 0.2, right? Black will go to the PLC because this is the input.
0.2.
This is the input, right? When the sensor will detect the object, right? When the sensor will detect the object, it will be sent through the black wire. Okay, so now I'm changing color here. What happened? Wait, delete it. Okay, you can understand, right? You can understand the things. So anyway, okay, fine, done. So now, and what about the blue? Blue will go to the
connect to negative.
Negative 24 volt.
connect to negative 20 volt, right? So here we have negative.
Sir, PNP sensor?
Yeah, right. You're right. This is PNP sensor. Okay, so I'm connecting here, so it's overlapping, but anyway you can understand, right? It's overlapping, but anyway, yeah. Okay, so it is connected, right? Okay, so here we have made the connection for the PNP sensor, right? PNP proximity sensor. Okay, so now coming toward the mushroom push button. Everyone knows the mushroom push button, right? Yes or no? Everyone knows it, right? So similarly, the way I have told you about the push button, the same thing you can observe on mushroom push button also. right? Same thing, 1, 2, 3, 4, right? NO, NC things. So accordingly, you can make the connections. Okay, yeah. So I'm giving you this task to you that make the connection for mushroom push button and send it to me. I will check it. Okay. Okay. So now coming toward the limit switch. Now, can anyone tell me what are the terminals for limit switch?
Common and
NO and NC.
Common,
That
NO,
stop button in series use limit switch.
will you please repeat, sir, what you are asking?
I think that stop button in stop button series we can use a limit switch. Any protection in field area.
Yeah. You are talking about the applications, right? Yeah. So for the
Yes.
applications, we can use the limit switch, okay, along with the stop push button also. The stop push button will be for the complete plant, right? But the limit switch will be work for the individual application where you want to implement it, right, for the particular operation. So you are right. We can use it in series. Yeah. Okay. So here, what we are doing now. So as per so here let us provide common. Okay, this will be the common. What is next? So let us okay, this will be NO, if I'm not wrong, right? And
NO and NC.
NO and NC, right? NO and NC. So this will be the NC. Fine. Okay. So now tell me the connection of this. So here you can select any relay contact, NO or NC, and you can tell me quickly.
According to operations, first the positive to common.
With negative.
Yeah. So common will go to here.
Common is a 24.
Yeah. Okay. I think
24 volt.
Yeah, 24 volt, right? So
Yes.
just a moment.
Positive 24 volt.
Yeah, positive 20 volt, right? So limit switch, finding something like this.
So third one, sir.
Yeah, just a minute. I wanted some realistic, so that's why I'm adding it here like this. Something like this, right? Okay, fine. This is limit switch. So now what we are doing now, we are connecting this common to the negative 20 volt, right? Yeah. The red here, I'm connecting it. We're connecting it. So red. Okay. So now you can use any one terminal, right? That may be normally open contact and normally closed contact as per the requirements, right? So during programming,
Sir, common code 24 volts, sir.
where it goes?
Common will goes to 24, right? You gave connection to minus V.
So you connect it. But we have taken negative as a common, na?
Okay.
No.
Take your time.
Common will go to 24 volts and NO will go to signal.
NO
means
will
we
go
are
to
using.
the PLC, right? This is the right answer.
Yeah, yes, sir. NO and NC both we can take to NO or NC, means depending upon the triggering system.
Right.
1 minute,
common
sir. COM NO NC. What is the? It is a sensor or relay.
Yeah, it is like switch. It is a switch.
This is limit switch.
NO is NC and we will be using different by using this when we are writing code in the program. Then that time we are using.
Yeah. Okay. So, okay. I'm listening everyone's answer. Okay. So now coming to the point. So this is NO contact. This is any one, right? So here we have selected NO. This NO will go to the
Yeah.
PLC, right? This NO will go
Yes,
to
sir.
the PLC. So here we have connected to the PLC. Now coming toward the important part, that is the common. This common will
24
go to positive 24 volt, right? Where it goes?
Sir, why? We have taken negative as a common. So how
No.
will current
Here we are
will
using
flow?
S by S. In 1 M we are using 0 volts, right? Opposite it will be 24 volts.
Yeah. See, so usually you're right.
Okay.
See, usually you can see, we know the common, we can say it's a positive 20 volt, right? Okay. But here you can see here, we have already made the common connections which are already available on the digital input side. Okay, digital input side. This is available, right? So if you are providing this common to the negative 20 volt DC, your limit switch will no longer turn on because there is no power supply to this terminal. Okay, so that is the reason this common will go to the positive 20 volt DC. Okay, this common will go to the positive. So here you can connect it here also. Problem. Oh yeah, here I'm connecting here. No need to confuse at all, right? These are very simple connections. Okay, so accordingly, what I'm giving you the task to one and all that. I'm sending this PLC hardware schematic with all of you. What you can do, you can do the such types of connections and send it to me. Okay, or I will send this task with by your name in a group, so it will be very effective. So because why I'm telling you, because when you are dealing with the photoelectric sensor, right? Photoelectric sensors is having the 5 terminals. Okay, so how to connect, when to connect, right? These things are completely depending upon the applications, right? So here right now we are using this is the normally open contact connection. Sometimes you have a requirement of normally closed contact also. So right now we are doing the connections here, and we are going to implement this connection in programming part. So after the PLC wiring, I will show you how to design the program for this connection part also. So your doubt will be resolved automatically. Okay. Yeah. So here I think the input connections are more than sufficient. Similarly, you can see here. Similarly, we have the analog input section also. Yes or no? Analog input section. So for the analog input section, you can see we have only 2 analog inputs, 0 and 1. So write down the task. I will also provide this task in group after the session. Your task is to make a connection for RTD, resistance temperature detector. Okay, your task is to make a connection for RTD. Okay, and send it to me. These are the tasks for the analog input. You can see, make sure that these are the 2M, 3M common terminal, and this terminal must be sorted. Okay, then and then the RTD sensor will work, otherwise it will not work properly. Okay, so now coming toward the next part, that is the output section. Okay, that is the output section. So let us consider that here we have provided the power supply, because we have already provided the power supply here directly. So now coming toward the output part. So on the output part, you can observe some different thing as compared to the input. Okay. So now what we can do, just a moment. Here, let me copy this. I'm pasting it here. So here I will show you quickly. See, output connections are very easy, right? So I think according to me, this is not a big deal, but just for the example, I'm telling you quickly. See, this is your green indicator, for example. This is the green indicator. Sorry. This is the green indicator, for example. This is our green indicator having 2 terminals. So here I'm like this. Like this. So these are the 2 terminals. Similarly, what you can do it for the other output devices which you know, and do the practice, and for any doubt we will discuss it live session. Okay? Yeah, these are the indicators, right? So accordingly, I'm just adding it for example. Am I audible clearly? Hello, no one is talking.
Yes, yes.
Yes, sir, you are audible.
Okay, see, these are the LED indicators. We can see it. So when you going for the purchasing this LED indicator in market, you will get the LED indicator to which you can provide AC power supply also and DC power supply also, right? Sometime you may purchase the LED indicator which require only 24 volt DC power supply, right? And for the sum you will have to provide 230 volt AC only. Okay, so anyway, so let us consider based on our requirement. You can see what type of CPU module is this. What is AC?
Critical power supply.
Right.
230 volt.
Yeah. So here DC means what? What is DC?
DC means input. Input 20 volt.
Yeah. This is the input, right? And this relay means what? Output, right? AC and DC. Right?
Output. Yeah.
Yeah. So here we are considering that we have the DC power supply, right? And if you have a requirement of single phase AC power supply, you can provide the external power supply also, right? That part also I will cover it later, but right now we will just see this part. Just keep in mind that if you have a equipment like a motor, right? 3-phase motor or a single phase motor, right? So for that purpose, you cannot provide the 24 volt DC power supply to the motor, because the motor required the 230 volt DC power supply, right? So for that purpose, you have to provide external power supply to the motor through relay. Through relay means in between this terminal and motor there will be relay, and this relay will act as a output, and that output signal will be sent through relay to your motor, and then motor will turn on and off, because the purpose of relay is to switching on and off the output devices, right? It's a simple thing. Okay. So now coming toward the basic connections of the LED indicators. Now tell me how to connect these LED indicators. Let us go with the green LED indicator. You can try. Always keep in mind the any one terminal of the LED indicator will go to the PLC. Yes or no? So now, as per the conditions and rule, we are connecting it to the PLC0 terminal of the PLC. Am I right? Is it correct? Yes.
Yes.
Yes. Yes.
Similarly, this one also. And okay, just make sure that the answer, your mic should be mute so that other participant will not disturb. Okay, in the same way it will go to the next, like this. Okay, so now tell me where to connect the second terminal of these indicators.
0 volts.
Are you sure?
Yes, sir. 0 volts.
Anyone?
Sir, 1L and 2L are the positive, right, sir? 24 volts.
Depends on what we connect to the common terminal.
No. 1L means positive. If not, if common is there means we will be connecting output side. It will be 0 volts. Whatever the input we are giving output means if we are giving 24 volts, it will come 24 volts only. If we are giving 0 volts, it will come 0 volts only.
Yeah. So now let us go with this part. Okay. 1L, right? This 1L will go to the positive, right? Because initially you will have to provide power supply to this output section, right? So, so let us provide this positive here. Is it correct? Is it right?
Right, sir. Right.
Oh, no.
So similarly, you can see here we have this 2L also.
2L.
So you can connect it here also. Yeah, too much noise. Please make sure to mute the audio. I'm happy that you people are answering, but getting too much noise. Song and all. Okay, anyway, yeah, you can understand. Okay, so now here we can see we have provided the power supply to these terminals. Okay, so this power supply will be internally looping for these terminals. Means the power supply, 24 volt DC power supply to this LED is already provided to this terminal 1N. So now tell me where this second terminal will be connected.
0 volts.
0 volt, right? It will go to the common. So can I connect it here, M terminal?
Yes.
Okay. So
Yes.
connecting to the M. Okay. Now similarly, can I do it like this? It is done, right? Okay. I think these connections are very easy. You can understand, right? So there is no problem with the connections. Once you understand the basic thing, you can do the any type of connections, right? Any output connection, no problem at all. Similarly, about the input also, you can see here. Let me present the screen. Yeah. Okay. You can see here just the two parts are remaining here. You can see the analog output. If possible, you can connect the analog. You can connect the VFD. Try to connect the VFD. Right? How to connect the VFD to the analog output, because this part will be done at last. I will cover in the drive section how to do these things. Okay, but right now you can try how to do it. Then the next part is here, that is about the analog input. I have already told you that try to connect the analog sensors. You know the analog sensors, right? So for that I have given you the example of RTD. You can take any 2-wire RTD or 3-wire RTD just for the example and do the connections. Okay, yeah, and this is about the output part. Okay, yeah, fine. So now coming toward the software part. In software section, you can see I have already provided the software, but I have the 15.1 version. So when you click on the folder, you will get this interface. Okay, when you click on the TI portal, let me show you that part also. Okay, so here is the folder, that is TIA portal version 15.1. When you double click on it, you will get this interface. Here you can see the start interface. Start interface means what this is, which you are observing. This is the start interface, right? Then here you are getting the options like open existing project, create new project, migrate project, close project, right? So this thing will be done when you have handled the software before. If no, then you can click on create new project. Along with that, you can see here there are some other options also that I will explain later. Okay, so let us go with the opening process now. Click on new project or create new project, and you can provide the name. Here I will provide the name like demo program just for the understanding. Program. You can do like this and click on create. Okay, click on here. Here is the path. You can see. You can change the path also. Just click here and you will get your the number of drives. Okay, value ED, etc., and you can select the folder where you want to store this programming file. Okay, so right now I'm not going to change it. Click on create. So when you click on the create, you will get the next interface, that is about the configure a device. You can see configure a device. Okay, Configure a device means what? Here, when you click on a configure device, you are getting an option add new device. Click on add new device. I will send this complete procedure, so no need to write this part. Okay, from my end I will provide it. Just see. Click on add new device. When you click on add new device, you can see the controllers, HMI, PC system. These are the options which you can observe in TI portal. When you are handling the normal PLC software, you are not getting the inbuilt software like this. Okay, but here you can see the controller is also given here. In controller part, you can see the S7 1200, 1500, 300, 400 is also given, right? Along with that, when you click on HMI, you are getting the different HMI, right? Basic panel, comfort panel, right? Schematic mobile panel. These are the different HMI versions are also given here. Let me show you few of them. So when you click on the schematic basic panel, you can see the HMI with the display, 3-inch display, 7-inch display, maximum display you can see here 15-inch display, right? As per your project requirement, you will have to select it. So initially we are going to start with the controller, then we will see about the HMI, right? So for the controller, you can see the S7 1200 is for the compact type, we can see it normally, and the 1500 we can see it for the modular type, right? So now let us go with the 1200 first. I will demonstrate both the controllers, so no issue at all. See, schematic 1200, here you can see the CPU, right? 11, 12, 11C, AC, DC relay. I have already told you, right? Now you people know what is the meaning of this, right? So when you click on the CPU model, you are getting the article number. These are the article numbers, CPU article numbers. And this CPU article number selection is completely depending upon the version which you are going to use. For example, here we have selected the first article. The version of first article is mentioned here, that is the 2.2 version, right? When you select the second one, the version is the highest version, that is 3.0. Similarly, the version is changing, right? 4.2. So what I am recommending you here is always select the highest version of that CPU model. So this is the highest version, 4.2. Why highest version? You can just see for the first version, what is the work memory? Tell me, what is the work memory here?
25 KB.
Similarly, when you go for the 3.0, the work memory is 30. And for the highest version, work memory is 50 KB. What is work memory? Work memory means what? When we people design the program in a PLC, that program is nothing but the work memory, right? And this work memory is erasable. We can delete the work memory, okay? And there is a one more memory, that is the system memory. System memory, we cannot delete it because the system memory consists of the number of instructions, symbol provided by the manufacturer, provided by the developer, right? So we cannot delete it. So this work memory is completely depending upon the what type of project you have selected, right? So based on that requirement, we will have to select the article. So in this article, you can see here, they have provided all the description. Means when you finalize the project data sheet, right? In project data sheet, you will have to mention all these details, okay? So here you can refer this detail in your project data sheet. The work memory in tabular form, you can put all these details. So 120 by 120 or 240 volt AC power supply requirement. And along with that, what they have mentioned the DI6, means digital input. How many digital input? 6. With 24 volt DC power supply, sync and source type. Output DQ, digital output. How many? 4 digital output. Relay type, AC or DC. And analog input. AI means analog input. 2 analog inputs are here, right? And the most important part which you can observe here, that is the 3 high speed counter. Can anyone tell me what will be the purpose of this 3 high speed counter? Anyone? You can try.
For scanning?
Counter.
Can it be for encoders?
Encoder, right? You're absolutely right. Okay, we can use these 3 high-speed counters for the encoder. Can we use the normal counter for encoder? Normal counters?
Depending on the speed.
Depending on the speed, very good. Depending on the speed, because when the motor, when your motor runs at high speed, there will be the number of pulses. We can see train of pulses, right? Train of pulses. There will be so many pulses. So if there is a more speed, the normal counter will not count. It will skip the pulses, right? So that is the reason when there is a more speed, we will have to go with the encoder. Encoder will be useful for measurement, speed measurement purpose, and that will be done by using the high speed counter. Okay, make sure that if you are dealing with such a types of project, your PLC consists of or includes the high speed counter also. Otherwise, you cannot able to measure the speed. Okay, you will have to go with the conventional way, right? Okay. Along with that, you can see the some other things also provided. That is the communication cables, right? Then what type of connections you can do it here. So here we can do the PLC to PLC communication also, and the PLC to HMI connection as well. For PLC to PLC communication, developer has provided the one important function, that is the interface module. We can see it IM means interface module, interface 360, interface 361. So by using that module, you can interface the multiple Siemens PLC with each other, right? Okay, so that part will also be supported to your system, because sometime we will have to interface the number of sections of the plant with each other. So at that time, you can use this feature of the PLC to PLC communication. Okay. So right now what I'm doing, I'm selecting this last number article, version 4.2, and after getting all the details and it suits to our project requirement also, then click on add. Okay. So when you click it on add, you are getting the hardware configuration and all, right? So you can do all these things properly. In modular type PLC, what we will have to do, we will have to select the input properly. We will see that part later, right? Because right now we are discussing about the SM1200. Okay. Yeah. Okay. So now it is taking time. You can see it's open now. So this is the next window. Here you can see this is our hardware. Let me zoom it so that you can observe. This is the real hardware. You can observe. Can you see this clearly? This is actual, right? So when you purchase it, it exactly looks like this. Can you see this?
Yes, sir.
Okay, you can see, right? These are the outputs, right? These are the inputs. Sorry, okay. These are the inputs. These are the outputs, right? How many inputs and how many outputs? Analog are not mentioned here.
6 input, 4 outputs.
Yeah.
4 digital output.
4 digital output and 6 digital inputs.
Digital
right?
input.
Digitals are provided here, right? Okay. So now before starting the programming part, what I will recommend is...
Sir, what about analog inputs, sir? In that specification, 2 analog inputs are given.
Yes, sir. Yes, sir. They haven't mentioned it here. We will add it, right? Okay. We will add it. They haven't seen it here, but there is an analog input also. Okay. Let me show you how to check it. Because every time you cannot observe these things on the hardware here directly. So that is the reason what to do. Let me tell you. Just double click on here on the hardware. So when you double click on the hardware, you are getting one window. That window comes with the detailed specification of the PLC. You can see general, IO tag, system constant and text. Just go to the IO tag and you can see how many analog input. You can see 2 analog inputs, right?
Yes, sir. 2 inputs.
Yeah, 2 analog inputs, 6 digital inputs and 4 digital outputs. Okay. Sometimes you are not getting these things on here, but you can observe in IO tag just for the confirmation. Okay. So we have confirmed that We have analog input also. The addresses are here. Sometimes we are in the confusion mode that what are the addresses. Every time when you select the PLC, you are not getting the address which will start from I0.0. Some addresses will be started from I4.0 also, depending, right? For the modular type PLC, such things may happen, okay? But for the compact, there is no issue at all, okay? So we have checked, we have verified that these are our addresses. Before preparing the data sheet, before starting the programming part, these are the important things which we will have to confirm. What the people are doing, they are in a hurry to design the program, right? Opening the window and started designing the part, okay, NOINC and doing all these things. These are the important things which we will have to verify first. Okay, we know the address start from I0.0, and for the output also it is started from Q0.0. For the analog it will be IW64. Okay, so we have confirmed it. Now, so what if you have prepared the project data sheet and you have finalized the terminal also? So now we have finalized the terminal, yes or no? We have finalized terminals. Okay, so now tell me what we have connected to the first terminal.
Normally class NC.
Stop push button, right? We can say stop push button. Okay, we can say stop push button. So what to do? Here you can provide the name. The name that will be stop push button. Comment. Stop push. Stop push button. Okay. Yeah. So now, okay, wait. Stop this here. Can directly provide it. Stop push button. Okay. So now coming toward the next, what is the second? Start push button, right? So let us provide the name, that is the start push button. Start push button. This is the actual method. Okay, start push button. Okay. Next, we have the NPN. We can simply write it proximity sensor. Proximity sensor, right? Yeah. What is next? Limit switch. Limit switch. Okay. So we have entered the inputs. Now similarly, let us enter the output also. We have output also, which we have already connected. Schematic. So green, red, and green LED indicator, red LED indicator, and hello. Right. So now you can see here we have provided the tag name, okay, so that it will be easy for us. If you want, you can provide the comment also, just for the understanding and adding the comment. That is the push button is the praise release operation, right? Praise release operation. Similarly for the stop push button and the start push button, praise release operation, right? And here for the sensor you can provide, right, to detect like this, to detect the object. It is very important to mention the tag name and the comment. It is very helpful for the person who is monitoring all these things and who is using this program and reading this program. Okay, so your task is to provide all the details. Okay, so if you are just providing the address, if you are not providing the tag, what is the name of this will be very difficult to understand, right? So to detect the object, any object, detect the object. Okay, done. So now just click it here. You can see, just click here. If this window will come down, will collapse, you can see, and click on the left side. You can see on the left side the start is mentioned here, right? Start. Click on start, and you are getting the project tree. This is our project tree. Okay, so here in you can see the name here, project tree, right? Okay, So under this project tree, you can see the things like a program block. Click on program block and click on main OB. During the first session, I have already told you that the OB1, right? The OB1 will be the main file of the programming part. OB means what? Organization block. Just double click on OB and you are getting the programming window here. Okay, yeah, this is our programming window. So in this programming window, you can see the main window. Under this, you can observe some variables. So right now we are not using it, so just click it here. It will go off. Okay, so this is our programming window, right? On the right side, you can see the number of instructions. You can see here. This is the instruction. Number of instructions are provided here. General, bit logic operation, timer counter. So many instructions are given here, right? So extend instructions are also given here, right? Technology oriented part is also given here, right? Counting, pairing, motion control and all, right? These are the instructions. Okay. So as per your requirement, you will have to select it. And the most important part which you can observe here, for this version, we are observing the instruction list. Only this much of instructions are available here. But when you are selecting the higher version, accordingly the number of instruction will increase. You are getting the number of instruction. Instruction list will be more for the highest version. This is the difference. Means if you want the instruction that is not available in the selected version, that will be problematic. That is the reason after the discussion with the client, we will have to design the simulated program, and that program will tell us that this is the suitable CPU module with the CPU article for our project. Okay. So right now, if you don't want it, you can just collapse it like this. Okay, like this. So you will get the complete programming window here. So as per the discussion that you can say it the network. Okay, instead of run, you can say network, number of networks. So this will be the first network. If you want to add the one more network, just click on the blank space, right click on it. When you right click, so when you right click, you will get the option that is the insert network. Just click on insert network, or you can use the shortcut key that is Ctrl plus R. This is the shortcut key. When you press Ctrl plus R, you are getting the one more network. This is network number 2, right? Similarly, network number 3. You can keep on adding the number of network as per your requirement, right? Like this. These are the number of networks. Okay. If you want, you can zoom it also. Okay, you can zoom it like this. This feature is also available in Siemens PLC. Okay. Zoom in, zoom out features. Okay. Yeah. By using mouse, you can do this. Okay. It's a very easy press key. Okay. So now here you can see the normally open contact, normally close contact, output file, and along with that, the Siemens has provided the empty box also. This is again the very interesting part. So this will be useful for the skilled person who have handled the Siemens PLC number of time, and he or she know the instruction of the Siemens PLC, right? For the beginner, I'm not recommending this. So you can just try. I will tell you how to use this box, because in maximum cases, if you know the instruction, simply what you can do, you can select it and enter the instruction name. You will get that instruction directly, instead of go to the instruction and finding it here in all the instruction. It will take time, right? Instead of that, you can directly use this box, for example, like this, and you can put the name, right? For example, you can see here we have selected this box, and here is the instruction. Just for your understanding, you can see this is the CTU, right? Counter. So what you can do, you can just put the name CTU and press enter. Okay. So when you press enter, you are getting the counter block automatically. You don't have to go to the instruction and select the counter block, right? The criteria is just to know the instruction, name of instruction, like CTU, CTD, likewise. Okay. So right now I'm deleting it. Okay. So now you can see the part that is the contact, NC contact, right? So on which network you want it, just select that network. For example, we want to select the number of contact on the network number 1. Select the network number 1 and select the contact. The contact will be added automatically. Similarly, normally close contact. Similarly, output file, right? These are the things, okay, which you can do. Now, the coming toward the next part, that is the parallel connections. How to connect the number of input in parallel. We have connected two input in series, but how to connect the input in parallel, right? So simply what you can do, you can connect it, click on the network before the contact, and here the manufacturer has provided the open branch option. Just click on the open branch and select the contact which you want to select here, and again click on the close branch. You can see we have successfully made the parallel connection, right? These are the parallel connections. Yes, sir. This is the parallel connection. Okay. Similarly, what we have to do, we have to do the other connections also. So now for the today we will stop here, and from the next session onward, what we will do, we will initially design the program for this connection, how to do the program for this basic connections, and then step by step we will see the basic part, that is the logic gate and all. That is very important part, right? Because when you are dealing with the control logic, you should know that part also. We will quickly cover that part, and then we will start with the first part, that is the bit logic operation, right? In bit logic operation, the manufacturer has provided so many features, like a NOT and state reset instruction, pulse oriented instruction, right? Pulse oriented output instruction, input instruction, and a block as well, right? We will see this part also, and immediately we will start with the one basic project, okay, and if application oriented simple project, so that you can understand how to implement this instruction in real time projects also. I mean, just to know the instruction is not sufficient, right? When you are dealing with the real time project and you know the state reset, right? But the problem is that you don't know where to use it, in what case we will have to use the set reset, or can we just use set reset normally anywhere? No, right? So we should know some basic fundamentals so that you can use this instruction properly in a project, right? So every time from my side I will try to cover this instruction with the industry application, so that it will be easy for understanding purpose. Okay. For today we will stop it here. If you have doubt, you can ask me. Otherwise, see you tomorrow.